Hi, I'm Dr. Paul Quinn. I'm from the James Hutton Institute, and I'm going to try and tell you about how to design and build nature-based solutions on Irish farms for flooding, or the very simple design principles of slowing and storing flood flow on farms. Okay, thanks to the SlowWaters team, Chaggers, and all the people who've helped me over the last 25 years. So, what are we looking for? There's lots of things to resolve: where, why, how, who. So here we are on a farm with some farmers and some experts, and suddenly I'm walking through the landscape and I say this is perfect. Okay, I then argue that this is the right place, and if I design a feature well, it will serve the purpose, or even multiple purposes, such as water quality, biodiversity, and other things. But remember, this is for flooding. Okay, this is if I was wanting to do water quality, I would be somewhere else on the farm. Right, can we store large amounts of floodwater on farms? Well, we've had some big storms to test us, such as Babette, and the answer is yes, but, and everything's in the but, you need to get the right flow in and out of your feature. So let's have a look at one we did earlier, and you can see a nice overflow here, and here's the pond with about 600 meters cubing. This is the bund. It's overtopping slightly, which is not good, but I'll tell you more about that later. So what to build? Well, you build the biggest storage pond possible from local materials, usually with soil, to about a maximum height of 1 meter. Tend not to go over that because it becomes more of an engineered structure. It needs more maintenance and more design. So here is a nice bund, and it's been compressed in using the digger. So we also asked the question, do water quality nature-based solutions address flooding? And that's been addressed by the Cork team, but there's a couple of things to bear in mind. The first is small features have small impact, but they can have some impact, but you need many of them to have kind of a flood level effect. If features are too small, they just won't work for flooding. We have to bear that in mind. If you do build anything, you're probably going to have some floods over your feature, which may cause them to overtop and to erode. So you must design in an overflow into your bund. Here's one we did earlier. Here's a nice sediment trap from the north of England, and it's very good at trapping sediment. It was taking about half the sediment out of the flow, but we also built in an overflow. So when the really big floods came through, the water overflowed. But this one did then go into a flood storage pond, so it all worked well. The sediment trap was protecting the pond. So the important thing to remember is that if you start to slow flow, then you must start to create new storage. You can't slow something down without it backing up and requiring volume. So if you cannot store the flow, then the feature will not work. It will be overtopped. And this, as we said, may cause other problems. So this excellent leaky dam from the Leeds site just gets overtopped in big storms, and it doesn't have enough volume behind it to make a difference. And the bund that I showed you previously from our farm in Wexford was overtopping. There was far too much water coming in. We weren't letting enough out. Therefore, it eroded this enormous hole in the bund. So you do need to get your design right. So let's have a little recipe for the steps you do for this, and then more detail in the next talk about some numbers and proof. So where to start? So you'll be in the landscape, and you'll be driving around with your gang, and all the maps you can get are good, and friends and farmers and experts. So you stop at the river. Maybe the scale of the river upstream is about 10 square kilometers. Too big, it's no good. We can't do work there. We could go to the top of the hill, and maybe there's a nice view, but there's not enough water there to probably do much intervention in terms of nature-based solutions. Maybe you'll improve the soil health or something, but in terms of flooding, probably little to be done there. But then if you move down through the system, you start to see your drains and your small channels, and this is perfect. This is what we're looking for. So my hint is find the first flowing drain on the farm, or a place where runoff is often occurring. Ask the farmer. Okay, so let's have a look at just a section of a farm here. And the red line is the boundary, the catchment boundary, and the fields and the drains. So what we're doing is we're searching for hollows and depressions or somewhere flat, like a floodplain, where a small bund could stop flow. And offline is always best, which means you have to wait for the water to rise and then spill into the feature. So you go for a walk from the top. So we were walking down talking about fencing and buffer strips. And then we got right down to the bottom of this drain on the farm, and we said this would be a great location for some online sediment traps to take out the sediment from the flow, as you saw earlier. But also this was a great place to spill flood flow in an offline pond. So we walk down here, and you've got to hope that at some stage you're walking down through the landscape and you have a eureka moment. A eureka, this is the perfect place. So we could spill water, flood flow into here. There was already a road here, so it's already storing some water, so we can come and optimize this to store flood flow. So that's what you're looking for. So all these maps are quite complicated. Some of the criteria for designing overflows and ponds, you need to go and ask an expert. Right, so how to draw off the correct amount of water. Okay, so working that out is really complex, and you really do need some help. You need to prove how big a storm is, how much is coming past your inlet, and how much to spill. But in terms of the design, you can either build up the bank or cut into the bank, depending on what your floodplain or your depression is like, or the depth of your ditch, or whether there's any embankments. So you can build up. So here's one at in Wexford, where we had far too much water coming onto the floodplain, and it caused the erosion, and therefore we raised the height by another 80 centimeters with these big logs, and therefore for most of the time the water goes past, and it was made from wood. The floodplain floods quite a lot, that's what floodplains do, but now we're controlling the rate at which it's inundating. On the other hand, we sometimes have rivers that are eroding downwards, and therefore the water's not going onto the floodplain. This is an enormous floodplain, probably related to glacial activity. And so what we've done is we've actually cut into the bank and built a swale that takes water all the way to the back of the floodplain to where we've got some ponds. We've armoured this to protect it from erosion, and you can see the bit of wood there controls the level at which the water spills. Okay, so you can either go up or down. How big is a pond? All right, so we use some complicated maps for this to get hold of this digital elevation data, which hopefully you can get from a source in Ireland. It depends on what resolution. You can get right down to 0.5 meter resolution, but on average you might be working with 1 meter or 5 meter resolution. But it's useful to have these maps, or at least to have a good Ordnance Survey map. So here is a map of 1 meter contours. So we've got a good map or a good digital elevation model with 1 meter contours, and I've highlighted this contour because this is where we want to do some work. There's a drain going past through the farm, and I know that I've got a good gradient here, so I want to draw off water here. I want to take it to this zone where the contours are far apart. This is a flat area. It's the corner of a field, which is perfect for flooding. You can see one here as well, but the actual wall runs across from here and then down there. So we can't use that bit. So we're going to use this section. So the simple way I do it is water will go in and come out using gravity. So I add a 1 meter high bund to the data. So if I put it right on the contour, I know that that 1 meter high contour will be 1 meter deep with water, and therefore it will stretch to the next 1 meter contour. And then usually it's approximately a straight line, usually, and therefore you can get the extent and volume of a pond. So if it's 1 meter deep, we can assume that the average depth is 50 centimeters. I can use little GIS tools to measure this. Turns out to be about 1800 meters square. So that's 900 meters cubed. So you can do it quite quickly if you know what you're doing. So I can do quite a lot of these in a day. So it is tricky. So you need to go get somebody who's good at GIS and knows how to do these tricks. So how strong are the structures for flow in and out? Well, here we have those big logs again. These are the big logs during Storm Babette. You can see they decided that they weren't strong enough and pushed them out of the way. and hence the overflow coming through the pond. Equally, the big eroded feature, which showed a weakness in our design, we've now rebuilt this to do two things. One, big and strong, and to take the right flow this time. So features must be strong. Okay, so how much water leaves the pond is also complex. You know, we learned the hard way with our first pond that I just needed to spend more time on it really to get the right flow out. So it is complex. You need to go and ask an expert again. But my simple rule is the peak flow out should be about half the rate of the peak flow in. So once you've worked out the flow rate coming in, and that depends on the scale of the channel, then you can have a good estimation of the flow rate going out. Or in this case, as you can see in the picture, my colleague is standing on a bund and we've put a big pipe in, but we can actually shut the pipe off if we want to. So you can have an adjustable draw off or an adjustable exit, okay, and then we can fix it after we observe some data, and we call this adaptive engineering. So really, the conclusion for now is flood ponds are really designed for flood flow primarily. You can design it for other things, but the location will be based on this hollow or the depression or the floodplain, okay, and getting the right amount of water in and out. So you will need help. I've said this a number of times. There are some things you can do and you can be trained up in, but other things you need to get an expert in GIS or an expert in hydrology, an expert in engineering. But there is plenty of capacity for on farms for flood storage. That is for sure. Okay, but how we do it is still, and who pays, are still there. So we need to learn together and we need to somehow pay together. And I would just say this, the weather is changing now and we must adapt. And there's great opportunities to make farming the front line of our adaptation for the future and solving water quality, carbon and other problems. But flood flow will be a major part of this story. Thanks very much.